Go there, open it up. And which chapter tonight?
Chapter 12.
I'm sorry, I didn't hear?
12.
Okay. To start at the beginning?
No, point 1.3. And then number 55.
Okay. I think I can do this without, just by doing that. What's the first thing that we know? Or, when you're looking at a function like this, start trying to figure out what you know about it. One of the most important things about a function are its zeros. So what are the zeros here?
1, 3, and 5.
It's not just 1, 3, and 5, though. It's what's their multiplicity, because that's going to matter also. So the one that's at 1, what multiplicity is that?
Squared.
It's 2, because of the exponent. In other words, that means x minus 1 times x minus 1. So there really are 2 zeros at 1. About at 3?
3.
And at 5?
2.
Now here's why that's important. If I have an even multiplicity, it does not go through the x-axis. It bounces off of it. If I have an odd multiplicity, it does go through. So in other words, I know I gotta hit that point and bounce off. I gotta go through this point, and I gotta hit this point and bounce off. So the only thing I really don't know, in other words, I could say that the graph's got to look like this. Got to go through that, come back, bounce off, like that. But it might be, in other words, I don't know if I got my end behavior right. Maybe it's this. So what's the next step? It's probably either the black curve or the green curve. How can I determine which one it is?
The total multiplicity.
I didn't hear you, Nicholas.
All the exponents added together.
Well, kinda. How about if we look at end behavior? In other words, what happens when x goes to negative infinity? Better yet, what happens when x goes to positive infinity? Well, that means you have infinity squared times infinity cubed times infinity squared. Well, that's infinity to the 7th. That is the green curve, not the black curve. In other words, what this test tells you is the right-hand end behavior. As x goes to positive infinity, does f of x go to positive infinity? And it clearly does. You never see a negative sign here. It's always positive infinity. So now, just to be certain, in other words, now I'm pretty certain it's the green curve, but just to be sure, what happens to the left-hand end behavior as x goes to negative infinity? Do I go to negative infinity or not? Well, what's negative infinity squared?
Infinity.
Turns positive. Then here I have a negative infinity cubed. That stays at negative infinity. And here I have a negative infinity squared. Well, these two become positive. This one stays negative. So as x goes to negative infinity, f of x also goes to negative infinity. And now I'm certain it's my green curve. So what I had to do was determine three things. I had to know my zeros, I had to know the multiplicity of them, and I had to know my end behavior. But that's it. Once I knew all of that, then I know my curve. It's the green curve. All right, let's do another one. Let me leave. The second one. Tell me the zeros and their multiplicity.
1 and 2, and 3 and 3, and 5 and 2.
So it's the same 3 points. I didn't need to erase them, I guess. 1, 3, and 5. This time, rather than drawing two curves, let's talk about end behavior first, because we know what we're going to do when we reach each of these zeros. We're going to bounce off the one at 1, we're going to go through the one at 3, and we're going to bounce off the one at 5. Now notice this is almost identical to the previous one, only there's a minus sign in front of everything. What would you expect this to be, my black curve or my green curve?
Oh, the black one.
Yeah, definitely. And I don't know, we can check just one point. Let's do it. Obviously, if we do positive infinities, we realize that our answer is negative infinity. In other words, if this whole part here is positive infinity, then the answer is negative infinity. And that's what's happening to our black curve. As we go in this direction towards positive infinity, our f of x, or g of x in this case, goes to negative infinity. Now, express g of x in terms of f of x. Remember, this was f of x. It's the relationship between those two curves.
They're opposite.
They're vertical reflections of one another. So what does that make g of x in terms of f of x? How do you reflect something over the x-axis?
Like the negative.
Yeah. So g of x is equal to negative f of x. In other words, I don't care which is which. One of them is the reflection of the other one over the x-axis. And that's what's important to see here. All right. I assume we just need to go in order.
Mm-hmm.
You do the first one.
Um,
In other words, forget their instructions. How do I add those two numbers, those two fractions?
the common,
Okay, what's the common
common,
denominator going to be?
6.
What's the left fraction in terms of sixths?
3/6.
And the right one?
2/6.
What's the answer?
5/6.
Next one. It's the least common denominator.
X squared. 2x squared. Yeah, 2x squared.
It's 2x squared. Now, here's how you check. If, in other words, by definition, each of these terms needs to divide into the least common denominator evenly. Well, 2x does, so does x squared. Notice that if I left the 2 off, now 2x does not divide into it. So I definitely need the 2x squared. But I can tell, I cannot prove that that is the least common denominator. But I can prove that it's a common denominator because both other denominators divide evenly into it. So what's the numerator over here?
3x.
And over here?
8.
And so the answer?
3x plus 8.
All over?
2x squared.
Yeah, don't forget the denominator. And that cannot really be simplified. Okay, how about number C? Least common denominator.
X plus 1, x minus 1.
And it's always a good idea to not multiply those together, just list them as fractions. And I'll show you why. What's the numerator got to be over here?
X times x minus 1.
That's why I don't multiply them together on the bottom. Because now it's very, very easy to see that that fraction is the same as what we started with. Because I can see that the x minus 1 cancels with this x minus 1, and I'm left with x over x plus 1, which is what I started with. So that's why I love this system of not multiplying the bottoms together. And how about the right side?
3 times x plus 1.
Okay. So the answer?
X squared. Minus x plus 3x plus 3.
Alright, all over x plus 1 times x minus 1. I know you can simplify that to plus 2x. And it does not factor any further. So I know I always am thinking, well, maybe one of those factors is either x plus 1 or x minus 1, and I should try to factor it, but it never factors. Not in 8 years of tutoring have I ever seen that numerator factor so that you could cancel one. So I kind of given up trying, if you know what I mean.
Mm-hmm.
Just, I know they're not going to make it factor. It's definitely x squared plus 2x plus 3, all divided by this. And there's no need to multiply the bottom together either. I want to point out one thing. I don't like the fact that all three of these were addition. Because when you're adding, you don't have to do anything special to this. If this was subtraction, then I would most definitely have to put brackets around that, because that entire numerator is being subtracted. Okay? And I don't like the fact that they haven't given us a problem that illustrates that, because 90% of the students I have will make a mistake when it is subtraction because they don't bother to put parentheses around it. In D, what is the common denominator?
Sine of theta times cosine of theta.
What's the numerator on the top left?
Sine of theta, or sine squared theta.
And on the right?
Cosine of theta.
So we get, is that right? Let's see, that gives you sine, now hold on. Yeah, that gives you sine over cosine, which is what we have, and that gives you 1 over sine. Okay, so now we have sine squared of theta plus cosine theta, all divided by sine theta times cosine theta. Question is, can we simplify that?
Yeah, no.
How? I don't see it right offhand. It'd be nice if this was a cosine squared theta, because then that becomes 1. But sine squared theta plus cosine theta, I don't think that simplifies to anything. Especially simplifying to something that would allow us to cancel one of these denominators out. I don't see it. I think that's probably the final answer. I might be missing something, but wouldn't be the first time. But I don't see it there. I don't see how we can simplify that. So let's go on. Watching CNN?
No.
No? I thought I recognized a voice there. Gloria Berger or whatever. Trump just fired James Comey. You know who James Comey is?
Nope.
The director of the FBI, in charge of the investigation into the Trump-Russian.
Interesting.
And Trump just fired him. All right, let's see. The next one. When it says rewrite it in graphing form, what's it really asking you to do?
I'll put it in Vertex Form.
Okay. Give me the general for Vertex Form.
Y equals a times x minus h squared plus k.
Good. How do I go about putting this in vertex form? Right now we got y equals 2x squared minus 4x plus 1. How do I make it look like vertex form?
Take out a 2.
Okay, our goal is going to be to complete the square, and we can't do that until we factor out a 2. So you're right, we're going to factor out a 2 only from the two terms on the left. I don't want to change anything. So far I have not. So far I've got the exact same thing I started with. Now what?
Take the second one and square it.
Sorry, what?
You take the second term of, or take 2 and square it.
Not 2, but half of 2. Got to divide that thing in half and then square it. So by completing the square, I'm going to write plus 1. Now how do I balance that out? Because I just changed the equation by writing a plus 1 there.
You add 2.
Not 2. I'm going to subtract 2. Remember, I'm on the same side of the equation. In other words, if I'm on the same side of the equation, I got to make sure I do the opposite of what I've done. And when I wrote plus 1 in there, I had added 2 to the right side of the equation, so I got to subtract 2. Now, it is true that sometimes when you're completing the square, you're doing it on the opposite sides of equations. And then you have to add 2 to the other side of the equation. But if you're doing everything on the same side of the equation, then you do the opposite of it, not the same thing. So now, put that in vertex form. Tell me what the final format is.
2x minus 2 squared.
Actually, whatever you got when you divided that thing in half. So it's x minus 1 squared. Square x minus 1, and you get x squared minus 2x plus 1. The process of completing the square guarantees that you can write this as a linear term squared. And what's the k?
Minus 1.
So now you know everything there is to know about this thing. What's the domain? Let's graph it before we answer the rest of these questions. Where's the vertex?
2 or 1, negative 1.
Does it open up or down? Now, tell me its domain.
Negative 2.
And
Infinity.
what was it?
Negative infinity to infinity.
Okay, what's its range?
Negative 1 to infinity.
Parentheses or bracket?
Brackets.
Where's the vertex? You gave me the vertex already. Where's the line of symmetry?
X equals 1.
Right there. And that's all we need. Okay, good. You have your calculator?
No.
Can you get it? These are calculator problems here. But I want to make sure we get the same answer, so I need you to have your calculator. Actually, maybe I don't. Yes, I do. because they want you to round it to 3 decimal places.
Okay.
Okay, go ahead and get it. And then I've got mine here also, and I'll be able to check you. Let me know when you have it.
My 1.356.
Well, tell me how you did this problem.
I took the log of both sides.
Common, natural?
Common.
So you got the log of 7 equals the log of 4.2, and then you can put the x there. So x is equal to the log of 7 divided by the log of 4.2. What did you get for that answer?
1.356.
What was the next decimal?
9.
Okay, read off the first 4 decimals you get.
1.3559.
Okay, good. Second one, notice that there's no way to solve that without logs. There's no way you can put that in your calculator and have it solved without logs. Actually, there is a way. Can you think of what it would be? How would I solve that if I didn't know about logs? There's a real clever way of doing it.
I have no idea.
No? Go into your graphing calculator, make y equal 7, and then make a second function, y equal 4.2 to the x. Wherever they cross is the solution. Now you might have to go in there and do a trace, depending on your calculator and stuff. But always remember that solutions lie at the intersections of 2 functions. And y equals 7 is one function, and y equals that is another one. So where those are equal is the x value. And you would get it to however many decimal places you wanted it. So you can actually do this without logs, although not that they want you to. They want you to use logs. So on the second one, what's my first step? Go work me through it.
Divide by 3.
So I get x to the 5th equals 126 divided by 3, which is 42. Now what?
You take the 5th root of 42.
How do you do that on your calculator?
It's you type in 5 and then go to...
Well, how about doing 42 to the 1/5 power? That's what the 5th root of 42 looks like. And take your answer and round it to 3 decimal places. Okay? And as far as I know, that's the only way you can do it on your calculator. Your calculator might have a square root symbol, might even have a cube root symbol. But it probably does not have a 5th root symbol. So you've got to do this using fractional exponents. All right, how about number C? My first step?
Add 10.
So I get 24 equals 2 times 4 to the x. My second step?
Times it by 2.
You mean divide by 2?
Oh, yeah, sorry.
All right. Can I solve this without logs?
No.
Okay. Next step?
Take the log of both sides. So log of 12 equals x log of 4.
So x equals log of 12 divided by log of 4. just in case you're wondering, that cannot be simplified. That is not the rules of logs involving subtraction or division or anything like that. It's only when the argument, if I had this, if I had the log of, and the entire argument was that, then I could say, okay, that's equal to the log of 12 minus the log of 4. But notice we don't have that. We've got the log of 12 divided by the log of 4. There's no simplifying that. You can't cancel the logs, you can't do anything. That's the answer. That'll give you a number in your calculator. And only in your calculator will you be able to get that number. You're familiar with the binomial expansion?
Yeah.
Pascal's triangle? Believe it or not, they are kind of the same thing. If I have a plus b to the nth power, that is always equal to n choose 0 times a to the nth times b to the 0 plus n choose 1 times a to the n minus 1 times b to the 1 plus n choose 2 times a to the n minus 2 times b to the n plus 1. You see the pattern?
Yeah.
That's not n plus 1, it's 2. Until we get up to n choose n times a to the 0, b to the n. That's going to be the last term. So, let's just do a straight substitution. What does this become?
1 or 4 choose 0.
You're right. 1 is it. What's the next term?
2.
What's this term?
A to the 4th.
Next term. Is there any b term?
No.
Because b to the 0 is 1. So there's never a b term in that first term. Just like there's never an a term in the last term. What's the next term? What's n choose 1?
2.
What is that? N is
2.
4. So here's what I've got. 4 choose 1, which is 4 factorial over 3 factorial times 1 factorial. What's that equal to?
4.
Okay. Next term?
A to the 3rd.
Next term?
B.
Next term?
6.
Next term?
A to the 2nd. B to the 2nd.
And next term?
4. A and B to the 3rd.
And the last term?
1 B to the 4th.
When I said Pascal's triangle, 1, 4, 6, 4, 1, that's how Pascal's triangle works. 1, then you have a 1 there and a 1 there, then you have a 1 there, and then you add the two previous ones, so you get a 2, a 2 and a 1, and then you get a 1 and a 3 and a 4 and a 3 and a 1. Where'd I go wrong? I went wrong somewhere. The coefficients of Pascal's triangle agree with these n factorials, these chooses, these combinations. I'm not going to try to find where my mistake is, but trust me, they do. All right, I won't erase anything. We still want this standard formula for what a plus b to the n is. This is the generic formula for, in other words, that equals that. So it doesn't matter whether you have a plus b or 3m minus 2. 3m is a and b is minus 2. So let's expand this one. So what's 1a to the 4th?
Just 1a to the 4th.
Well, what's a? In other words, we're no longer dealing with a and b. We've got 3m and minus 2.
It's 81 to the 81m to the 4th.
Good. Plus. You know, rather than trying to do all that complex math in your head, it's really easier if you just list the combo and the number. In other words, here's what I'm suggesting you do. The next term is 4 choose 1 times 3m to the 3rd times minus 2 to the 1st, right?
Mm-hmm.
Just write out every term like that, and then we can go back and simplify it. What's the next term? Written like this.
4 choose 2, 3m to the 2nd, negative 2 to the 2nd.
Notice how important parentheses are here. Super important. Now I ran out of room, so I got to erase something. I'll erase this down here. I'm going to finish this thing down below. Okay? So pick up. What's the next term?
4 choose 3. 3m times negative 2 to the 3rd.
And finally, the last term.
4 choose 4. Times negative 2 to the 4th.
Notice one thing. 4 choose 4 is the same as 4 choose 0.
Mm-hmm.
They are both 1. Just the way you do combinatorics. They are both 1. 4 choose 0 is equal to 4 choose 4. And it'll always be like that. In other words, this coefficient there is going to be the same as that coefficient right there. Okay? Okay. Now, let's write the entire answer across the top, starting over here. In other words, what we've given them is just not quite a finished answer yet. So, what's the second term? What's 4 choose 1?
Gosh. 4.
What's 3m cubed?
27 cubed.
What's minus 2 to the 1?
-2.
Again, I don't want to do this math until I have to. I'm going to fill it in like this just so that I do not make any mistakes. What's 4 choose 2?
6.
What's the next term?
3m.
Well, go ahead and square 3m squared, so that becomes 9m squared. And then what's minus 2 squared?
4.
And the next term. 4 choose 3.
Which is 4.
Times 3m. What's minus 2 cubed?
-8.
And finally, the last term, we know that 4 choose 4 is 1. Minus 2 to the 4th is 16. So now, still got to go through and simplify. That term is correct. This becomes minus, what's 8 times 27? Your calculator.
216.
M cubed. This is plus, what's 4 times 54?
216.
M squared. This is going to be minus 32 times 3 is 96m plus 16. There's your answer. That's what 3m minus 2 to the 4th power is. Now, that seems like a lot of work. We could have almost done it that fast if we'd have just multiplied everything out, right?
Yeah.
But what if it was 3m minus 2 to the 14th power? Then this method is going to be much faster using the binomial expansion. The only thing I'm a little bit surprised here is that they don't tell you what to use. In other words, their directions don't say use the binomial expansion. What happens if I hit hint? Do they give me a hint?
Yeah.
But not really, huh? I gotta go back. Alright. I was just curious whether they pointed out the binomial expansion theorem. It's hard for me to believe that they're asking you these two questions without thinking that you're going to solve them by using the binomial expansion. That really is about the only way to go. I mean, we could do it manually, but there's a point where the binomial expansion becomes quicker, but there's also a point where it's slower. All right, let me read this. Well, let me think for a second here. 8 toppings were available, and 1 pizza was made for each of the possible combinations of 3 or 4 toppings. So there's 8 different toppings, and there's a pizza that has 3 or 4 toppings, and between all of the pizzas we get all 8 toppings. Am I interpreting it correct?
Oh, I think so.
Yeah. Now the question is solving it. It's a lot harder. I am not good with these kind of problems. I will be frank with you. I do not tutor probability and statistics for exactly the reason that some of these problems can really get hard. I mean, you can make probability problems that would tax a PhD in math. And since I don't get a lot of requests, I don't tend to stay on top of this. So this is not my strong suit. I can kind of take a guess as to what the answer might be, but it's kind of going to be a guess. How many pizzas were on the rack? Do you have any idea how to do this one?
No.
Let's click step A and see what they say. Find how many, with 3 toppings can be made. Okay. So there is 8 choose 3 types of pizzas that can have 3 toppings. Well, how many is that?
56.
So we got 8 factorial divided by 5 factorial, 3 factorial. So we got 8 times 7 times 6 divided by 3 times 2. Okay, so you're right, 56. So there are 56 different ways that you can make a 3-topping pizza with 3 toppings, given that you have 8 toppings. What do you suppose step 2 is going to be?
I may choose 4.
Okay. What's 8 choose 4 equal to?
B.
So 4 times 3 times 2. That cancels with that. That cancels with that. I have 70. So I have 70 ways that I can make a pizza with 4 toppings. Unique ways. Although, yeah, order doesn't matter, and that's why it's a choose problem, not a P problem. It's not a pick, it's a choose. Because we don't care if I've got pepperoni, green pepper, and onion, or onion, green pepper, and pepperoni. It's the same pizza, right?
Mm-hmm.
So that's why order doesn't matter. Now, 1 pizza was made for each of the possible combinations. Well, we got 56 pizzas was made for 3 combinations. 70 pizzas was made with 4 combinations. So I'm saying there's 126 pizzas on the rack. Maybe, maybe not. 126. Okay. What's the probability of getting a pizza that had mushrooms on it? So there's 126 pizzas. How many of them have mushrooms?
Um, 7 choose 3. Plus 7 choose 3.
What would that give you? That would be 7 times 6 times 5 over 6. That'd be 7 times 5. That'd be 30. So we'd have about a fourth. Actually makes a little bit of sense. How'd you come up with that? 7 choose 3.
Because you're taking one topping off because you need a mushroom, so it's give you 7 and 3.
Okay. Keep making the same mistake. If mushrooms are a known topping, then you can choose one fewer topping from only 7 remaining toppings. You see their answer?
Yeah.
Not quite what you said, but you were close. In other words, your logic was very sound, which was to remove one topping. But remember how we got our 126. We had 8 choose 3 plus 8 choose 4. So it should be 7 choose 2 plus 7 choose 3 is going to be the number of ways that you would take away a mushroom. This is still hard for me to follow the logic here. I can see that if we only had 7 toppings, but it seems to me like our answer should be the reciprocal, not this, but 1 minus this. In other words, isn't this the way that if I look at this answer, seems to me that that is the number of ways you can make a 4-topping pizza without mushrooms. And this is the way you can make a 3-topping pizza without mushrooms. Right? Makes sense? I mean, if we only had 7 toppings, throw out the mushrooms, our answer would have been 7 choose 3 and 7 choose 2. Excuse me, 7 choose 2 and 7 choose 3. No, wouldn't have been that. No, because we still have 3 toppings on each pizza. So I'm a little confused. I'm not sure I totally understand how we get this answer, but I get it. Kinda. Still not sure I totally get it. You totally get it?
Kind of.
Good. Good. Some people have a knack for probability and combinatorics and permutations. I'm not one. That's not my strong suit. So I will go on. It's the end of that. Do we go to 12.14? Next?
Yeah.
Which one on this as a beginning? 1267?
Yeah.
We only have time for maybe one more. Oh boy. I love this integrated math. Where do you go to school, Nicholas?
Thunder Ridge.
Since when did Thunder Ridge start teaching math in an integrated style? In other words, every question bounces between trig and combinatorics and probability and algebra, and that's integrated math. There's very few school systems that teach that way, and I didn't think Thunder Ridge was one of them. I thought Thunder Ridge was just like the other three schools in the Highlands Ranch area, where you took algebra and geometry, and the next year trig, and the next year precalc, and during that whole semester you deal with just with those subjects. All right, this should be pretty easy for you. What's the sign of A?
A over C.
What's the secant of A?
B over C.
Secant is the reciprocal of cosine. So it's got to be C over B. What's the cosecant of B?
C over A.
No? Here. The things you got to know are your reciprocals. So the secant of A is 1 over the cosine of A. Okay? Well, 1 over the cosine of A is B over C, so that becomes C over B. Let's do the cosecant the same way. What's that 1 over?
B over C.
What's the reciprocal of cosecant?
Sine.
Okay. Sine of B. And now sine of B is what?
B over C.
Which means this is C over B is the answer. And finally, the tangent of B.
B over A.
All right. Good place to end it. I'll remember where we stopped, I think. Do you make a note where we quit?
Yeah.
Okay. Nicholas, have a good night, and I'll talk to you next time. I think tomorrow we have a session.
I have no idea.
I believe we do. I think your mom made sessions almost every day. Let's see. Yeah, we do tomorrow at 5:30 and then Thursday at 8. So just the next 2 days.
Okay.
Okay?
Yep.
All right. Talk to you tomorrow.
Bye-bye.